Welcome to another video on time series analysis. In this video I'm going to explain how to solve least square method, in that too using fitting a linear trend equation. We have many methods in least square method, in that too here I am going to explain about fitting a linear trend equation. Let us know something about linear trend equation and the least square method. LCM method or least square method is one of the most popular method for fitting a mathematical trend, which is very widely used statistical tools for fitting mathematical trend. In this method we find a best fit for the given data set points by minimizing some of the offsets or residuals of points from plotted curve. We minimize by taking deviation from the x value given in the problem. As I told you, here we will take a deviation. When we make the deviation, the sum of the deviation of points of various points will be 0. And this is a very best method for obtaining trend values. Here our intention is to obtain trend value, especially in each and every data set available in the problem we will get trend value. So it is very important to know, it is very important to understand how to solve, how to fit linear trend equation in least square method. Let us understand what are the formula we use here to fit a linear trend equation. Very importantly, we have a formula of linear trend equation is yt is equal to a plus bt. Here t is a time interval and a and b are basic variables. Firstly, we will obtain a and b. After obtaining a and b, we will find trend value. So this linear trend equation is a basic equation, and a normal equation a and b. To obtaining a and b we use some other normal equation that is a subsidiary for that basic equation. Then let us know what are the formula we use to obtain a and b in this case. So here a is equal to summation y. We are having some data sets of sales, profit or demand, whatever, that summation y, the data must be summed and divided by the number of n, then we will get a. So we are also want to derive b value. To obtain b value we use formula summation xy by summation x square. Then using x and y we need to find out what summation xy and summation x square. Yeah, before that we also need to obtain t bar for calculating xt values. Here t bar is summation t by n. We need to add all the times, and that times must be divided by number of n's, number of times. These are the very basic formulas you need to follow for fitting linear trend equation. Firstly, you need to obtain a and b. After obtaining a and b, you will apply to the basic equation, basic linear trend equation, that's yt is equal to a plus b, and t is a time interval. We obtain time interval using this formula for each values. Then let us have a problem for this. So here we have a problem. Fit a straight line trend by the method of least square to the following data. We are having some of the data here, years 2010 to 2017, and sales rupees in lakh from 2010 to 2017. Using these data we need to fit a straight line trend by the method of LCM, and we need to assume something like rate for trend value is same, assuming the same rate of change continues. If it is continuous in the same rate, what would be the predicted sales for the year 2018? We don't have any data relating to 2018, but using the rate that are going to change, we need to estimate, we need to predict the trend value. And also for these data we need to calculate trend values from 2010 to 2017. So let us solve this problem using following formula by one. Firstly, we need to obtain t bar. T bar is equal to summation t divided by n. So let us obtain each points here. We using the formula. Here we have a formula, t bar is equal to summation t divided by n. Here we are having different years that can be taken as considered as t, which means time. Here time is year. In another cases time may be week, time may be month, time may be quarter also. Here we have 8 years. We have added all the years. Total value of summation t is 16,108, and n number of n is 8. We are going to divide 16,108 by 8. Then we got the value 16,108 by 8. So t bar is 2013.15. So which means there is a intervened value between 2013 to 2040. It will be basis for taking deviation. So t bar is this. After finding t bar, we need to go for xt. I will show you how to obtain xt. Xt is simply t minus t bar. Imagine these years are t1, 2, 3, 4, 5, 6, 7, 8, and when we want to t for each txt, for each y values, we need to take a deviation from the something like assumed value. For that we will use this formula. Then let us take each values t. Let us take a deviation value. For 2010, xt is 2010, which will be t is 2010 minus t bar. T bar is 2013.5. So deviation point is minus 3.5. And for 2011 we will follow the same equation, the same formula. So xt is 2011, so t is 2011. Xt means x value in the t, time interval 2011. Here also same time interval 2011, which will be subtracted by 2013.5. so deviation point for 2011 is minus 2.5, and for 2012 deviation point is minus 1.5, and for 2013 deviation point is minus 0.5, because 2013 minus 2013.5 minus 0.5, and for 2014 plus 0.5, because 2014 minus 2013.5. Simply I am following this formula. The formula is xt is equal to t minus t bar. We have also already found t bar using this formula. T bar is equal to xt by n. So we will take a deviation, and let us see for 2015 also. For 2015 1.5, and 2016 2.5, and for 2017 3.5. And I will stop here because we are only having 2000 years from 2010 to 2017. So we got a deviation point. So when we apply this deviation point to the data set, these are the given values. Years, year considered as x, xt, time interval 1, 2, 3 like that, and sales, we will consider sales as y. So yes, we have obtained a deviation point for each value each year. For 2010 deviation point is minus 3.5. Here I have inserted minus 3.5, and 2011 minus 2.5, 2012 minus 1.5, and 2013 minus 0.5, and so on. I have just inserted all the values. And here I have also found deviation point for 2018, just because they have asked us to predict the values in the same change. So if it goes in the same change, we will get change for 2018 would be 4.5. Anyhow, I will consider here only up to 2017, because these are the basic times. So I told you when we take a deviation, it must be equals to 0. Summation xt that must be equals to 0. So which is 0. Then let us proceed further for further calculation. In this calculation we obtained xt value, deviation points. After obtaining xt value, we can obtain x, y and x square. So here here is x. I have given the mathematical symbol within the bracket, and sales is y, and we also obtained xt. In the earlier slide you came to know how to obtain xt. Now we have to obtain xy, xt into yt. So here xt is this minus 3.5, and yt is this 76. Then 76 into minus 3.5, so xt into yt is minus 266, and so on. 80 into minus 2.5, 200. 130 into minus 1.5, minus 195. 144 into minus 0.5, minus 72. 138 into 0.5, 69. 120 into 1.5, 180. 174 into 2.5, 435, and 190 into 3.5 will be 665. So firstly I will take positive values here. After taking positive value, I will add negative values also. So totally I will subtract from highest point to lowest point. I got plus 616, which is summation xy, summation xt, xt yt. So after finding xy, we also need to find x square. So x square in the sense xt square. So minus 3.5 into 3.5, 12.25, minus 2.5 into minus 2.5, 6.25, minus 1.5 into minus 1.5, 2.25. Simply I have made it xt square, so I derived same values from minus 3.5 to plus 3.5, and everything is same. So here 0.5 into 0.5, 0.25, and 1.5 we already calculated here. We can just carry the same values for 1.5, 2.5, and 3.5. We also obtained summation xt square. Summation xt square is 42. Now after finding this xt, xy, x square, we can apply to the formula. Formula in the sense normal equation. Okay. Basic equation is yt is equal to a plus bt, whereas to satisfy basic equation we need to find out normal equation. Normal equation in the sense we need to find out the values of a and b. Okay, I have already explained what the formula we use to calculate a and b. So for calculation of a, the formula we use is summation y by n. Here sales is summation y, and n, number of n is 8 years here. So 2010, 1, 2, 3, 4, 5, 6, 7, 8. N is equal to 8 here, and summation y is 1052. So 1052 by n we will get a value. Okay, 1052 by 8, a is equal to 130.1. So now in the normal equation we found a value, and let us also find b value. For finding b value, summation xy divided by summation x square, which means summation xt into yt divided by summation xt square. We have all the datas here. Summation xt here, summation xy here 616, summation x square is 42. Let us divide summation xy by summation x square. So I have just applied to the formula 616 by 42, and b value is 14.67. So using the formula we also obtained a value, b value. Now what else? They have told us to find trend values from 2010 to 2017. So after obtaining xt, yt, xt square, now we can find finally trend values. So to find a trend value we need to go for a linear trend equation. I told you what is linear trend equation already. Linear trend equation is equal to yt. Y means sales at particular year. Let's say we can consider 2010. For that we need to have a trend equation. So linear trend equation is yt is equal to a plus bt. So a let us find here I have inserted a value 131.5, b value 14.67. just we found these values in the earlier steps. Now let us apply that linear trend equation to the formula. Let us find trend equation for 2010. Yt is 2010 and a value 130, 1.5, b value 14.67. Now what is T? BT, we have just inserted B, and what is T? Time deviation at 2010. Time deviation at 2010 is minus 3.5. So when I simplify this value, I got something like 14.67 into minus 3.5, which will be 51.345, plus into minus. So 131.5 minus 51.345 will be 80.155. This is a trend equation for trend value for 2010. In the same way, let us find out the trend value for 2011 also. Here A and B values are same, but deviation point time for 2011 is different. For 2011, minus 2.5 is a trend deviation. So 14.67 into minus 2.5, which is 36.675, plus into minus, and from 131 bigger value, positive bigger value 131.5 minus 36.675. So trend value for 2011 is 94.825. In the same manner, let us calculate same trend value for rest of the years. So example, for 2012, trend deviation is minus 1.5. When I subtract 14.67 into minus 1.5, so I got 22.005. So 131.5 minus 22.005 will be 109.5. And for 2013, trend deviation is minus 0.5. 14.67 into minus 0.5 will be 7.335, and 131.5 minus 7.335 will be 124.165, which is a trend value for 2013. And for 2014, plus 0.5 is a trend deviation. So when I subtracted that with 14.67, it would be 7.3375. And when I add here plus into plus 131.5 plus 7.335, 138.835. So in the further for further years we need to add, because we are having positive trend deviation. For 2015 trend deviation, here trend deviation is for 2015 is 1.5. So I have considered 1.5 here. 14.67 into 1.5. So I got value of something like 22. When I add these together, 131.5 into plus 22.005, 153.505. And in the same way for 2016, so 2016 2.5, 14.67 into 2.5, so I got that 36.675 plus 131.5, 168.175. And the last year, for last year trend deviation is 3.5 plus 3.5, 14.67 into 3.5, so which is 51.345. I will add 131.5 plus 51.345, which is 182.845. So by this way we found trend values for 2010 to 2017. So now we need to estimate the values. So now we need to predict the sales for the year 2018, and they have told us same rate change, if it is the change in the same rate, goes up. So for 2017 same rate trend deviation was 3.5. So if the change goes in the same rate, example, I have shown you how the changes are went from 2010 to 2018 in the last slide only. Example, in 2017 change was 3.5, and in the same rate 2000 xt is 2018 minus 2013.5, the change rate for 2018 will be 4.5. Now let us apply to the basic equation. So just like 2017 how we found trend values, also we can find the trend values for 2018. Here A value, B values are same, and trend equation is 4.5. So 14.67 into 4.5 would be 66.1015. When I add these together, 131.5 plus 66.015, which would be 97.515, which is the predicted sales for the year 2018 if the change goes in the same rate. Yeah, we found trend values and everything. Now let us look all the values in the one frame. Here I have inserted trend values xt, x square, x w, x xy, and xt sales everything. So it which is available in the one frame. Finally, we found trend values for 2010 to 2017 using basic equation. Now let us insert these values into the graph. So these are the actual sales and trend values also inserted here. Now look at this graph, and the y axis is years from 2010 to 2017, and here on the left side x axis is sales volume. So you can see two curves here, one is yearly sales and one more is trend value. Here we have a zigzag value, this value relating to yearly sales, and trend value is straightened to the upward trend. So these are the computed trend lines for the data of sales given in the problem. And in this video you learned how to fit linear trend equation under least cost method, sorry, least square method, LSM. So we if I want to summarize this least square method, here we have two formula. One is basic equation, that is yt is equal to a plus bt, and we need to find normal equation for a and b. After finding normal equation, we have to find out trend values, and using the same rate we estimated to the given year, that is 2018, and finally we plot those values in the graph. Thank you so much for watching. Please do subscribe to my Vision Academy YouTube channel for further more videos. Here you are also having merits of least square method. You can go for further study, and also I have listed here demerits of least square method. So you can have a further study. I have sourced these materials for preparing this video. Thank you so much for watching.